Welcome back to the CyberSG Voices podcast. Today our topic of discussion is Agentic AI. AI agents are no longer a concept, they are already running inside enterprise systems, government, infrastructure and small businesses right now. But as they act, adapt and make decisions autonomously, a critical question emerges. Who is actually watching? Today we have three guests at the sharp edge of the Agentic AI question. And we will explore what oversight means when the agent moves faster than a human, and what happens when AI is both the tool and the threat. So welcome. Yeah. Maybe we can start by each of you introducing yourself and what you do in the area of Agentic AI.
My name is Gaurav. I am the CEO of StrongKeep.com. We're building the future of cybersecurity for the smaller businesses of the world. The way in which Agentic AI and AI as a whole has changed the way we do things is fundamental. A year ago, we would not have been able to build the tools that we're building today at the speed and quality that we are, and we would not be able to operate them for the number of customers we have without the use of AI. Agentic AI allows us now to be able to deploy tools, operate and manage them on behalf of smaller customers 24/7. And that's a fundamental shift in how we think about technology for cybersecurity.
Thank you for having me. I'm Prity. I'm co-founder and CEO of Nestria AI. So at Nestria, we started with the mission to advance reliable intelligence in the world. And the topic of today is exactly at the core of what we do. It's essentially, how do we ensure that the AI systems and the agentic systems that we're building are trustworthy by design? I'm based out of Singapore and really pleased and glad to be here today, and we'll share more of my thoughts later. Thank you.
I'm from A-STAR. A-STAR Institute for Infocomm Research is one of the research institutes under the umbrella of A-STAR. I work there as a senior principal scientist and head a group of researchers and a research team working on network and system security that includes AI security today. What we do is basically look into challenges in the space of cybersecurity and develop solutions which have been mostly using AI models, from all the way from statistics to traditional machine learning to now we have the LLMs, right? So that way we look both into cybersecurity challenges, but also where AI is part of a solution, and then we look into the challenges due to AI being deployed.
So back to the question I started off with, right? We know that today Agentic AI is widely deployed in a lot of infrastructures, whether government or enterprises. But this question of who is watching them, I think is important to answer. But the other question is also important, right? Do we need to watch them at all? So maybe I'll start with the lady first. Prity.
It's a very interesting question, and thank you for that. It's at the core of what autonomous systems mean, really. So if we have too much control, then it loses its purpose and its objective, the meaning of autonomous. But if we do not have the control systems in place, then we really don't have a way to know whether we have, or we can truly trust the system to help us and work with us, be it making transactions on our behalf. We are having talks of agentic commerce these days. Be it actually interacting with it by sharing our core information, sharing enterprise data, sharing more and more IP sensitive information. Or it could also be around how do we think about robots in the future, or really having physical AI and embedded and embodied AI. We want to find that right balance. Do we need autonomy and autonomous systems? Yes, but the right way to go forward is to design systems which we can trust from the core, and hence the word for that is controlled autonomy is what we are looking at.
Yeah.
Thank you.
Yeah. So maybe I'll come back to that later on. Gaurav, maybe for you consideration. So my question to you, and this is an operational question. I mean, you've deployed your technology for at least a year and a half now. Have you ever received a call in midnight from the customers and said, "Hey, Gaurav, your Agentic AI is not doing what it's supposed to do. Tell me what's going on," or something like that?
The answer is no. My number is not on the website. But frankly speaking, so it relates to the question Prity just answered, and it's do we need to watch it? Do we need to understand it? There is a select group of individuals who need to understand what it does. Yeah. But the vast amount of end users or customers don't. And I liken it to plumbing. There's a lot of engineering in that. No plumber will ever explain to you why it works that way. It's the same for agentic AI. The end user does not need to understand how it works so long as it works. But there is a group of people who need to understand how it works. And the level of scrutiny they put on it depends on how much they trust it. So that level of autonomy that you give it is a function of risk management. Quite fundamentally, all of life, not just cybersecurity, all of life is a process of risk management. How much trust you want to give to a tool versus how much you want to have oversight either in the loop or on the loop depends on your level of risk tolerance as well.
So, Dinil, from a research perspective, what do you think of what has been shared by Prity and Gaurav?
It's interesting to hear their perspectives. It's important to know, depending on where you place the AI models, what risks are involved, whether you should observe it and you should act on that observations. So I think from that perspective, I would say you need to consider the scenario of deployment, and in those deployment, what is the impact of any particular risk, and then take it from there. Right?
So just to put things in perspective, I've been seeing this particular TikTok that's floating around now in the social media about two cleaning robots at the Changi airport, being very polite to each other because they ran into each other. Each saying that, can you give way? The other say, no, I'm not going to give way. The other say, can you perhaps move to the left? No, I cannot. But everybody standing around them was trying to help them, So in this case, I think it's one aspect of risk that may not have been considered at the point of design. My question to the panelists is this: during the whole construction, engineering, and design process, how do you prevent this?
I think when you gave that example of the robots, they are not having the intended behavior at that specific context, at that specific moment in time, and they are unsure what decision to take. Now, that's a classic sort of challenge when it comes to designing autonomous systems or agentic systems or robotic systems, where this kind of decision trees, when you know which path to take, is okay for humans to take, because we know we have SOPs in place, and we know if we are stuck, who to go to, which department to go to if we're doing an analysis. But for robots or for agentic autonomous systems, same principles of design and innovation should apply, because what we are emulating here is an artificial neural network. So three things here, if I kind of put it into more structure. So one I would say is trust by design, but then having an innovative, adaptive mindset as you're designing the system, so that you know that the agents are they're adaptive and they're interactive, so they can actually learn and have the self-learning loops that once they learn something, they can embed in their memory and can kind of solve that issue much faster. And this decision of who to kind of give pass first when there's a two robotic situation can be designed as a self-learning mechanic in the core design itself. The second is what we call as, in more technical term for it is traceability, but the more normal term for that would be, hey, if this issue is being kind of reported to then like a head of operations for the airport, then does he know that what made the robots clash? So it speaks to like traceability and visibility of the decision making itself, or the reasoning steps itself. And the third aspect is ensuring that your governance is scalable, because you have two robots right now, but in future, ideas, enterprises, and in operations and marketing, anything would adopt more and more autonomous systems. That's the aim. So you want to ensure that this governance is not just designed for just two robots in play, but multiple robots, and it's a collaborative effort between builders, researchers, and adopters.
You have anything else to add on this?
There's 2 points I want to just echo but build on a little bit. First is this idea of deterministic versus probabilistic software. You're right that algorithmic, kind of the traditional software that we built with robots is deterministic, and it's going to end up stuck in the same loop forever. It cannot adapt to a different context because it's not part of its programming. Probabilistic means that it's going to try different things, but in and of itself, probabilistic does not lead to learning. An autonomous system that just operates on sheer brute force probabilistic trial and error is not a very smart agent. There has to be some form of learning. You can brute force the first time. Real life is messy, and when you deploy agents to the real world, they will encounter a mess. It's not possible to design away all of these problems, and I don't think engineers should try to, But what engineers should be trying to do is to design a way in which the system encounters the problem, tries different things, learns from what works and what doesn't work, and then takes it back as a feedback loop. And that way the agent gets better and better and smarter and smarter.
Now, perhaps it's also important to ask ourselves today, where are the limits of agentic AI today? Like, for example, in the instance of helping SMBs, beef up their security, cybersecurity abilities, right? What are some of the decisions being made by the agent when they're deployed for the SMB?
So last year, the struggle we had was how do we take in information from the World Wide Web, make sense of it, and pass it to a small company that needs to understand what the threats are. That was a complex problem. We spent a lot of time and wasted a lot of tokens trying to ingest a whole bunch of threat feeds and intelligence and news, make sense of it, tag it, parse it, and present it in a format that was digestible and usable and useful for smaller companies. We have a threat intelligence agent. We recently re-engineered it. It took us maybe half an afternoon, and none of us actually touched the engineering of it. So the way in which we think about engineering agents has changed. The second point, which I will pass to Dinil, is when we started researching how we're going to use agentic AI to support smaller companies, the hardest unsolved problem for us was how do you orchestrate multiple independent agents to work together? And that was an unsolved problem 7 months ago. 3 months ago, it's open source by one guy. One single person has, in his free time, vibe coded a solution to orchestrate multiple agents, made it public, and today there's dozens of different harnesses out there to allow orchestration of agents. What was once a complex research problem that 5 PhDs would have struggled with for a year is now something I can deploy with a single line of code. The implications of that are staggering. Agentic AI has really transformed how we think about deploying security for smaller businesses.
I think Gaurav made some excellent points, which is coding is perhaps one of the examples where agents have shown their capabilities. And with that, it's just not enterprises, but even researchers, we are able to prototype something really pretty fast. That's a big plus point. If you look from a security perspective as well, many things have now become easy with an agent. For example, if you want to see what is the reputation of a particular domain, like I give this classic example of phishing, which everyone understands. An agent can today kind of figure out, right, whether a given web page, does it look like a well-known website, an e-commerce website like Amazon, for example. And previously you would need to write a huge program for that, and you need to train models. And actually, as researchers, we have done this, right? And now that bar has been lowered. So I think that learning with more data and better models, we have reached so far, like with really good capabilities today.
Mm-hmm. So in other words, with the current technologies, actually you can take care of a lot more scenarios that were not previously possible before. Can
I add something to that? Because we are talking on the implications of on security and everything, right? So upon the release of, or the preview of Claude's Mycos model, the company had to hold it off before release and set up a task force for Project Glasswing, just because they realized that the capability of this AI model is that it can break into any safety critical environment. They had to put up this task force and get all the industry heads together to really solve what AI can do to disrupt the systems that we have built on. So that's one very in the moment example of what AI is capable of from a cyber standpoint.
I've got this question, okay? What is the smartness of agentic AI? And we know that actually from psychology, there's a system called metacognition. I'm not sure whether you build it into your AI. It means to say that whatever that you're doing, all right, you have a level of cognition that's operating above. So it goes back to the question of who is watching? Because actually, technically speaking, you can have the agent watch itself, all right, because it has another level of intelligence. How do you structure such intelligence into your AI?
So building on that, and also kind of going back a little bit, I'd like to first take a moment to kind of make a differentiation between model capability and agentic capability. So models are the heart of what agents we are building on top, but agents are much more can bring much more complexity just because they connect with many data sources, they make decisions, and they have access to many information which in wrong hands can go very wrong or can be manipulated, where agents are being orchestrated to work together in a multi-agent system. That's a great outcome for enterprises when they are implementing agents across customer workflows, operational workflows, internal core workflows, manufacturing workflows, anything. But then the risks also compound because they're all connected. I'd look at it from 3 lenses. First is this a system that we have designed governable or not in the first place? Human in the loop is one type of control gate. It's not the only control gate. There could be many other control gates that you can put in to ensure that the system is governable in the first place. Second is whether we can have the right monitoring and observability in place. And the third is whether I can have the ability to act and control it. So, for example, do we have a fallback plan, and do I have a redundancy in place to ensure that, or maybe if I activate a kill switch for the robot, what will happen then? I can't have my system just go dead. I need to have a fallback, a redundancy. It's a must question for enterprises and model builders and researchers like field experts to ensure that the adopters needs to be kind of protected by implementing these 3 things.
I think Dinil, you may chip in as well. The question is whether there's a standards for agentic AI framework. So Dinil, as you construct your engineer and research on your agentic AI, right, is the frame different from what Prity has highlighted, or is there a standard frame out there right now?
These are actually active discussions, right? Currently, like there are active discussions on these topics. There are regulatory boards that are coming up with these suggestions on who would be accountable when it is extremely high risk versus when it is a deployment issue, right? There are a few things which I think Prity mentioned some of those, right? So one is we need observability, like if there is a chain of agents, which agent drops the ball and leads to something wrong. So that needs to be understood for a few reasons. Of course, we need to understand the safety and security of these systems, but also we need to know which model and which agent made the mistake so that we can also go back and help in the learning process, right? So we need observability, we need attribution to which agent in the whole workflow, right? So this is a life cycle of agents that we need to consider, and we also need to keep in mind that there's a chance that the fine-tuned model might deviate from the original model in terms of safety alignment, right?
Gaurav, with your regulatory experience, seeing how many of such frameworks get adopted, developed, etc., I think you have a lot of insights to share on this.
Yeah, I mean, so there's 3 worlds. There's what we should do, what we can do, and what we do. What we should do is there is a whole bunch of standards and guidelines and frameworks around the responsible use of AI, and IMDA has some guidelines. There's ISO 42001, which came out last year, and it was a very compressed cycle. It's already outdated. It is already irrelevant. It is a 1-year-old ISO standard that nobody's going to implement because it's based on thinking about your model. And nobody today is deploying the model. So the model becomes abstracted to a commodity that you either use an open source model or you use a commercial model, but nobody really cares that much anymore. So the idea of what we should do in terms of governance is an ideal world, but the challenge is what we can do is a lot of very dangerous things. What we do with it actually then becomes a function of real on-the-ground risk management. I can vibe code a lot of stuff, all of us can. None of us are going to vibe code our banking app, but I will happily vibe code something that integrates with my note taker, something else that makes it faster and easier and more efficient for me to do it. I'll vibe code a whole bunch of low risk, low impact things. The challenge now is when you flip this to red team. So this is all the blue team thinking, how do I want to use AI? Red team has the opposite incentive. I want to use AI as fast as possible, as much as possible, to break in and steal data, money, whatever it is. So they are pushing the boundaries. The difference in speed of use between the bad guys and the good guys is that gap that creates risks for all of us, which then means, again, risk management. Maybe the blue team should turn the governance a little bit down initially so that they can catch up and then turn it back on later. But is that viable? Is it possible to be insecure by design at the start and then secure by design later? We've seen this play out in software, and it's always a bad lesson to learn. So the dilemmas are very real. I don't have a good answer for it, but these are the dilemmas you will face.
We know there are a few groups of people that are involved in this design and engineering of the agentic AI agents, right? Of course, the developers, the researchers, the engineers, and so forth. But actually, one of the biggest group out there are the users. What kind of tools are we giving them so that they're in more control?
Yeah, I mean, it's a difficult question. I'll step back a little bit and ask, should humans have oversight over the technology? Yes. Because there's an assumption in there that humans are necessarily better and good. And if you think about the history of humanity in the grand arc of technology, technology is a tool, and it is humans that have made it do bad things. Over and over again, we learn that you create image generation, which allows us to create beautiful imagery, and immediately you have cyberbullying, deepfake nudes, and all these horrific things that humans ask it to do. So the problem is not really, how do we give humans more oversight? And the question is, for what decisions and what context should humans be involved in the decision, and for what should they not be involved in the decision? One of the simplest and easiest examples to understand is self-driving cars. Just came back from San Francisco. We sat in a Waymo, which is a driverless taxi. They're not bad drivers. The risk of an accident, if the entire road was all self-driving cars, is an exponential order of magnitude lower than if you have mixed driving or all human driving. So then the question is, do you want the human to be able to swerve the car and jam the brakes and press the accelerator? Or would you rather disable that function and, have an emergency release for whatever reason? And that may be a different mental model around thinking of it, where the system is designed to keep you safe. There is an emergency release. There's an emergency brake. But you can't take over the driving because you're not a better driver. And I'll just end with this, all data is normally distributed. So whatever the AI system is, it's most likely going to operate at the 50th percentile, assuming it's not learning, it's not clever. So it's better than half the people out there. It will not be as good as the best 49%, but it's not bad to eliminate the worst 49% from this equation and then let the good drivers carry on. So it is a different question entirely about philosophy of control rather than the technical tools of control.
As humans get smarter, get more involved, I believe that humans will get more and more inquisitive. And to the point that there's also a possibility for us to tell the system, hey, look, perhaps you can look into this particular area and which there's a possibility for the agents to improve in terms of performance. Because at the end of the day, we really can have a lot of perspectives of all the issues we discuss. But the question is this, what kind of value is it going to bring, right? If the arguments of all the perspectives is going to bring nothing, then actually technically this effort may not be worth pursuing. I think from my own perspective, hearing from all the experts panelists, is that it's important to ask ourselves what kind of value are we pursuing at the end.
Are you solving a problem that people care about? If that problem affects a large enough number of people and your solution is able to address that problem, that's a very pragmatic way to approach it. In the space that I'm in, and bringing this back to agentic AI and human oversight, the people that I'm solving a problem for don't have the time, talent, technical talent or budget to intervene in the oversight of the AI. These are layman users who operate bakeries, clinics, law firms. They're not technical users who want to tune the model and refine how it's learning. They just want the thing to do the job it's paid to do. Then there is no need for oversight. There may be some need for some accountability or governance, but that may be on the engineering side rather than the end user side. So the decision of where oversight and AI's learning comes in really depends on the use case and whether or not the users who are paying for that problem to be solved want it or need it.
Ultimately, it's about adoption of technology and why we want to kind of adopt something. What is the value? Value is to make human lives better and empower everybody and bring more parity. But still, in the context of where we operate, there is a aspect around accountability where the agents ultimately are machines. And when the decisions are being made, and the point that Gaurav made was spot on, like at the top of the pyramid, there would be a human who would be accountable and responsible for why his company or why his department or why his agent did and said something or made a decision for that matter. The human in the loop for him in this context would be that he needs to have that capability and data points and trail and like at the end of the pyramid to understand and review why this was done by the agent. And that accountability sits with a human, and for him, that is what human in the loop means. But in the context of an engineer, what Gaurav was saying, exactly correct. We need to define human in the loop for who and in what context. Is it the builders, or is it the adopters, or is it the regulators? And the criteria and the needs for the players in the ecosystem.
I think we can abstract this out as a risk assessment framework. You want to hit efficiency as much as possible. If it's related to law enforcement or human rights, then you want to bring certain things as close to zero as possible. So you can model this and then decide what are the risks that come out, how does it impact the regulation or the user or the businesses, and then how do you put mitigations in place.
So with the discussion that we've had before, actually we've spoken about being pragmatic and knowing the outcome for which the agents are designed for. If you are talking about the red team agents, you're talking, these guys have been designed with the outcome of destroying things. On the blue side, they are meant to perform certain functions that are good for enterprises, etc., etc. My question to the team is this: do you see your agents going rogue, and for what reasons?
No, it's a great question, because the idea of your agents going rogue, I mean, it's the Hollywood sci-fi movie killer robot problem lah. The space that I'm in, let's say for cybersecurity, my job is to protect smaller companies against, let's say, a virus. It is entirely possible for some malicious person out there to trick my agents, to make it learn the wrong things, to make it confused, and be overprotective. I mean, I can't destroy their offices, I can't burn down things, but I could fry all their laptops by accident. We could take a set of decisions which causes my agent to think that the best way to protect this company is to disconnect all their laptops, or maybe even to format their data. So that's the horror, the fear that I have, that with the best of intentions, my systems will perform a set of actions that it thinks is doing the right thing, but may end up doing fundamentally wrong things. This is the interim, the near term of what you're going to see about rogue agents. We are still a little bit away from killer robots, fortunately, but the trajectory we're on does give us some pause for caution. There are things that society and governments need to consider about how to govern all of this to prevent those kind of outcomes from happening. Even the self-driving cars need certain heuristics on how to deal with children running across the road, stray dogs in the middle of the street, because all of that affects how society thinks about how we should be using this technology and the risks that it brings in.
So just to put things in perspective a little bit, right? We all know that given any technology, there's no such thing as a perfect technology. So we should not be too hung up, that kind of things. But again, focus back on the pragmatic aspects. What else can we, improve in terms of business solutions, performances, security, and of course research. We touched on the important issue just now regarding the protection of this agentic AI technologies. Dinil, from a research perspective, I'm sure you have a lot of insights into this area, all right? It is also said that with agentic AI, the future of cybersecurity attacks is going to be massive and in high scales. What are your thoughts on that?
What changes with AI in comparison to, let's say, a decade back, right? So basically, we are going to have a relentless capability that is not tired, is not emotional as an attacker versus who was a human previously, right? And the tools that the attacker is now really familiar with because it's programs. So what we have here is scale, which means efficiency at which you can create these attacks, and effectiveness. It's very clear with what we have seen in the recent past. These, I think, require a different kind of approach to solve this.
What are some of these research areas that you're focusing on from an A-star perspective that will address the issues that we have raised?
So for many years, we have been looking into how AI can help build cybersecurity solutions. So whether you look into detection of malware, detection of phishing or scam and so on, or network attacks, right? So how can these defenses be enabled through the use of AI? This problem has been there even before because some of these data are actually humongous. Like if you look into network traffic is humongous in size, right? You want to find ways in which you can detect malicious network traffic. You actually need an AI model. You always needed an AI model. With our communications being encrypted, there's only so much that filters can do. We work in this space where we use AI to scale up the solutions, and the idea is to take research in this direction to commercial solution and as fast as possible. So as Gaurav mentioned previously, so the red teamers are moving really fast. So we as defenders also need to move pretty fast. And A-Star is positioned to work in the ecosystem, collaborate with the right people to push the boundary. Yeah.
So I've got two questions, right? We have said that the red team has this ability now to scale tremendously. But on the other side, what I'm hearing from you is that the blue team could correspondingly do so as well. At which point in time are we going to see a equilibrium, coming into being? You see that happening?
Never. Absolutely never. This is an adversarial system. Every adversarial system is like a chess game. I will move first, then you move after that. And unfortunately, there is a huge incentive on the part of the bad guys to continue pushing their boundaries. The dark web is a $6 trillion economy. They want to make more money out of ransomware, out of scams, out of all of these things. Technology is one tool, AI is a different tool. And I think agentic AI will be one of those opportunities for us to try and move a little bit faster, a little bit less shackled by the constraints we've had in the past, and try to get as close to defending ourselves from the bad guys as possible.
I'll just add to that if you let it be on the adopters to think about security and think about trust and think about how do we protect, it might always be an afterthought, but then there are ways to kind of bake in the improvements as the technology advances. Now, one example which I feel is, yes, in Singapore being championed by CyberSG, CSA, and globally across EU ecosystem and other markets as well, is the focus on leveraging this power of technology, AI or agentic AI, for both AI for CyberSec and CyberSec for AI. And I do see, like, through CyberCall, within Singapore itself, there are a lot of effort being done by your team and efforts from CRPO on how do we kind of build this from ground up to really leverage the power for both sides of things.
So with the kind of opportunities that are available and is there for us to tap in terms of AI, agentic AI and AI, there will be a lot of potentials for research. I know StrongKeep and A-Star has been working on a project together for some time now. Gaurav, maybe you want to share a little bit on that?
I think it's been a fantastic collaboration. I also wanted to echo the thanks that Prity gave to CRPO for enabling this project to happen. In order to deliver cybersecurity at an affordable rate in a way that works autonomously and operates continuously for a smaller company, we can't just outsource to cheaper providers. We have to redesign the very fundamental architecture of delivery and operations of cybersecurity for small companies. And that involves a whole host of technical challenges about how you understand what a cyber threat is. A company like StrongKeep understands this business problem, but we can't solve this problem on our own. And that's where working with researchers who think about this, who have the expertise and the knowledge and the skill sets to tackle some of these very cutting edge problems has been very beneficial to us. So it's been a great collaboration. It's early days still. Many of the challenges that we're dealing with are being dealt with at the world level. And hopefully the end outcome of all of this is that we solve a problem. We solve a problem for a customer that's struggling with it, that doesn't have an answer for it, and this collaboration will yield that exact result.
Actually, what you said is correct, right? And it resonates, of course, with CRPO together with TIG as well. That actually, at this current time, it really offers a lot of opportunity to redesign things at the core. Dinil, since you're in the thick and thin of the research, could you maybe add some insights to what Gaurav has shared?
Thanks, Gaurav, for the kind words, and thanks to CRPO for this project as well. We were together in this even before the project was awarded. We had a common goal, which is to understand the problem from a user perspective. So that helped us to formulate the problem in a very structured way so that the researchers can then address them. And it doesn't stop there. So we also interact very regularly. We have deep technical discussions, and that also helps us to move at the pace in which the world is moving today to solve this problem.
So the afternoon, I think, has been well spent. A lot of insights, a lot of questions that arose, and of course, we all know that there are still many more questions that are yet to be answered. Now, given what we have discussed, what would be one of those takeaways that you want the audience to carry with them after this podcast?
Well, I would say AI is very important for cybersecurity, and cybersecurity is also very important for AI. That's just the only takeaway I want to send. Yeah.
My takeaway is twofold. One is technology is powerful but amazing. We just kind of have to keep pace with it and understand and foresee how it can be leveraged for both defenses and for right offenses to strengthen our defenses, but ultimately to deliver value to the consumers, to deliver value to the enterprises. And the second is, we have research, we have builders, we have ecosystem partners. I think there's a very, very important aspect about a collaborative ecosystem because of the technology moving so fast and the industry in general trying to kind of keep pace with it. The ecosystem collaborating with each other, every player in the industry needs to play an active role, and there will be more and more kind of opportunities and more faster way to solve and address those opportunities by a very, very collaborative approach among everybody in the ecosystem. So that's what I think, collaboration and keeping pace with the technology for really, really delivering the value for the mankind.
Thank you.
I'm going to echo the point on collaboration and also add another point on democratization. None of us are as smart as all of us. I am an open source contributor as a developer, and I love the idea that many people come together to solve some sort of technical problem. Whether it's researchers and industry, whether it's engineers on the internet, many people coming together to solve a problem is a beautiful part of humanity, but it's also a necessary part of how we get progress. Democratization is actually another key takeaway for me in terms of how agentic AI has shaped how I think about technology in the future. Cybersecurity used to be a luxury good. It's something that only the enterprises and the biggest companies in the world could afford. With AI and agentic AI, we now have a real opportunity to democratize access, to give the smallest guys a chance at using these tools to keep themselves safe. The cost of building and operating all of this is dropping every single day. The cost of building your own enterprise tools is dropping every single day. This means that we now have an opportunity for technology to make a difference, not just to the rich, to the ones who can afford the best tools, but to everyone. And I think that's a great takeaway from my perspective of how the value that we're bringing is not just limited to a few, but to many.
So thank you very much. On the aspect of democratization, I totally, totally resonates with me. So I believe that access is so low now, and anybody can actually embrace cybersecurity. So on that, actually, I'm inviting the audience. I mean, if you've heard something that interests you, there's a lot of opportunities and really chances for you to get involved. If you have enjoyed watching this, do follow CRPO on LinkedIn and YouTube for more of such content.